Hello, I'm Nick from Trendmicro. Today, my session topic is Ghosts in Your Network, How Kurma stays hidden and exfiltrates your data. I'll share the TTPs used by the APT group, Kurma, regarding how they maintain low profile in victim environments. So let's get started. So this research is done by me and by my colleague Sunny. We're both senior threat researchers in Trendmicro, and we're responsible for tracking APT attacks in APEC regions. And here's the outline for today's session. We'll start from introducing the APT group, Kurma, followed by the analysis details of their tactics, techniques, and procedures. Then we will discuss how we attribute their activities and conclude with some takeaways. We've also published the first part of our research to our official blog. In today's session, we'll share more arsenals like load, victory, downbegin, and simple WebEx spy. So let's get started. So, who is Kurma? It's an APT group which has been actively targeting entities in Southeast Asian countries. Our observations indicate that they have started their attack since November 2020. Their primary objective is to exfiltrate valuable documents. Additionally, we also find that this APT group can possibly be linked to known APT groups like Tardycat, Lensfly, Tunnel Snake, and Sharp Dragon, which is also known as Sharp Panda. So for the targets, it shows that this group has significant interest in government institutions and government-related telecom services. This map indicates the targeted countries in Southeast Asia, including the Philippines, Vietnam, Brunei, Malaysia, Thailand, and Indonesia. So to the next part, infection chain. Now I'll briefly introduce their infection chain. The attacker first compromises the victims by leveraging the web vulnerabilities. In the lateral movement stages, they use open source tools like NBT scan, Laden, and so on. To maintain persistence, they deploy some kernel rootkits like KRNRate, Moria, load to hide their footage. They also use backdoors like testdate and downbegin. In order to exfiltrate data, they use customized tools like Simple Box Spy and Simple WebEx Spy. We'll go into detail of each stage later in the presentation. So here's the timeline for the loaders and backdoors evolution. We first observed downloader in November 2022, followed by testdate, loader, and downbegin. To date, they're still using testdate, loader, and downbegin. And here are some highlights for the TTPs we found during investigation. First, they use highly customized tool arsenals for different victims. Second, they also use sophisticated techniques for defense evasion, like they have multi-stage and reflective loading rootkits with backdoor capabilities. There are also memory-resident usable agents for rootkits. They even abuse Cisco WebEx for CNC communication. They also abuse DFSR mechanism for malware deployment and data exfiltration. And they even exfiltrate data over Dropbox, OneDrive, and Cisco WebEx. So let's continue to the in-depth analysis. So for the aroused vectors, based on the observed cases, the attackers compromise the vulnerable web servers and then drop it malicious tools. As you can see, a malicious file, dp.exe, was deployed through the Tomcat web server. Then a malicious service called CTT was created, and another scheduled task was also created to execute dp.exe. For the lateral movement stage, we found several tools like NBT scan, Laden, WMI hacker, FRPC, and so on. For most of them are covered in our blog, so I won't go through them here. For the persistence stage, we observed that the attacker implemented multiple rootkits, backdoors, and loaders for persistence. Like there are rootkits like KRN-rate, Moria, and mmload. For loaders, there are downloader, test date, dmloader, and downbegin. So let's first introduce the first rootkit, KRN-rate. It's a full-feature backdoor with lots of capabilities, like process manipulation, hiding files or directories, hide network connections, inject shellcode, and CNC communication. And this name is derived from its PDB string. As you can see, there's a specific word, KRN-rate, here. And as you can see here, this rootkit was built upon multiple open source projects, as listed here. This means that the threat actors are good at building their own toolsets by reusing the open source codes. And as you can see on the right, this rootkit can protect processes from being killed, hide files or directories, or even hide traffic IP or port. And its usable agent shellcode is loaded from a .dat file and injected to service host.exe at the end of the execution. So which means that the usable agent is always memory resident. And based on our analysis, the payload is a stager and can hide processes and connections. And the final payload from the CNC server should be what is called as manager. For the second rootkit, Moria, it was first disclosed in 2021 in the report Operation Tunnel Snake. It's a traffic interceptor for hiding the malicious payload in the TCP traffic. So it works like the right image. It finds the targeted incoming packet by checking its first 6 bytes. The malicious payload will then be injected into the response packet. And also, its usable agent could issue a specific IOCTL code, like 222004, to register the 6-byte magic number. And in this variant, we found it has an additional shellcode injection capability. It also loads a .dat file and injects to service host.exe, just like KRN-rate. We suspect that the final payload should be also its usable agent. And it uses nt-create-thread-ex to execute shellcode. And in order to bypass hooks, it enumerates ntdll and get the syscall number to invoke it directly. For the third rootkit, mmload, it's a multi-stage and reflective loading backdoor packed with multiple rootkits and components. First appeared around April 2024. It has lots of capabilities like DSE bypass by loading rootkits reflectively, or it can hide files, directory, registry, keys, and traffic. It can also protect processes from being killed. It can also inject payload to all processes, or even steal your RDP credential or do the CNC communication. This tool is kind of complex, so we separate its execution flow into 3 stages. So in stage 1, an MSI installer will be executed and installed. And in the second stage, multiple rootkits are reflective loaded and executed. In the stage 3, the rootkit will load various payloads from your registry and continue the CNC communication. We'll further expand their details in the following slides. So in the first stage, inst.exe executes setup1.msi and drops 3 files. The dropit passbat.bat will execute a legitimate WinIR binary, ir.exe, to decompress the password-protected archive, kernel.ir. In stage 2, multiple files will be dropped from the archive, including 2 payload zlib files, 2 driver files, 1 batch file, and 1 registry file. So the batch file will install 2 services called boot proxy or NSDI proxy, and also install mm.reg. So both drivers will load the zlib files. These payload files are not signed. Both drivers use reflective driver loaders for bypassing the Windows driver signature enforcement. For the MM filter, it tries to install a hook on every mini filter's pre-operation callback to hide the files, like nsdi proxy.sys, tcpip.sys, and the file path specified by the registry key, portet path. In the stage 3, a nsdi proxy.sys will be dropped. It has capabilities like inject payload to all process, hide files and registry keys, or protect specific process, or remove all the hooks registered by OB register callbacks for anti-scanning. And it will also load the next stage loader, MM module. So basically, this driver first loads the registry payload, MM protection. And in order to trigger the payload injection routine, it will first install a hook by ps-set load image notify routine. And then when the image ntdl is loaded, it will install another process hook by ps-set create process notify routine. And then payload will be injected whenever a new process is created. So based on the targeted process, it has different behaviors. If the target process is ccsvchst.exe, it will try to kill it. Or if the process is regedit.exe, it will inject the payload called hidreg.dll, and it will try to hide the specific registry key used by mmload. And if the target process is mstsc.exe, which is Windows Remote Desktop, it will inject the rdpsif.dll. And it will try to steal your RDP credentials and save to a specific file called kb911.911.log. And it's also based on an open source project, rdpsif. And it will also inject to all of the 64-bit processes. And also, it will try to hide specific files by hooking the Windows Filter Manager. So if any of the files are found, like boot proxy, kb911.911, and so on, it will return a fact path, which is tcpip.sys. And next, it will try to load a loader called MM module. It will load the final payload called module win11. For the final payload, it will hide the current processes by unlinking the 3 doubly linked lists in Windows. And it will then do the CNC communication. For the final payload, module win11, it will also try to control the NSDI proxy with specific arguments like anti-scan or anti-GP. So based on the strings, it could be correlated to the loaders used in another APT called LensFly. And we also observed several loaders and backdoors in the persistence stage. The loaders, downloader, test date, and DNloader usually comes with specific export function like start or init. Most of the final payloads are Cobalt Strike or CoBeacon. For DNloader, it loads the embedded payload, which is called Victory, also known as Victory DLL. There are two variants for the backdoor downbegin. One communicates to a CNC server via route TCP. The other one is quite interesting because it communicates via Cisco WebEx. And this is also the first time we find an attacker abuses Cisco WebEx service. Let's first introduce the final payload Victory, also known as Victory DLL. It was first used by Sharp Panda, also known as Sharp Dragon, since 2021. And it contains a 3-byte NOP padded configuration block, just like this. It contains some information, like the CNC address and port. We can see that the variant used by Sharp Panda is slightly different from the one used by Kurma. The one from Sharp Panda has more functionalities. So we suspect that this malware might be shared among multiple APT groups. Let's take a look at the interesting backdoor downbegin. So it's a novel backdoor first appeared since November 2024, and it's usually invoked by run DL32. It has capabilities like reverse shell or file manipulation. And it also comes with two variants. For the variant A, was based on route TCP. For the variant B, it's based on Cisco WebEx. So in variant A, it was based on route TCP, and it also has a unique mutex. It also tried to read configuration blob from 32 bytes from end of file. It contains CNC address and port. It has an additional INI file which controls its execution time. All of the Windows APIs to be resolved are encoded by CSAR cipher. And it can work as a passive or active backdoor. As you can see here, it supports the capabilities to manipulate files or execute commands. It can also list, delete, copy, upload, or download files. For the variant B, it has similar capabilities to the variant A. However, this variant is quite special because its CNC communication is based on Cisco WebEx. Multiple meeting rooms will be created and used for command and control channels. It first load two INI configuration files. As the left table shown here, the WebEx launcher.ini contains information like client ID and client secret that could be used to connect to Cisco WebEx service. The variant will collect your system information and save it to integrity.txt. It contains data like your hostname, memory size, and IP address. There's also a specific major number, 408D374C, which appears in both variants. Here's an example picture of the response obtained from the WebEx server. There will be 4 meeting rooms created as communicating channels. The keep room is served for keep alive beaconing. The message room is the main channel for command and control. The file room is for file manipulation, and the shell room is for command execution. The file and the shell room will only be created when specific command codes are issued. Here are the command codes for the variant B. For both variants, they share almost the same command codes, and functionalities like listing, removing, copying files, and so on. For the final stage, exfiltration, the attacker used tools like PowerShell, Aldris, Simple Box Spy, and Simple WebEx Spy. So the exfiltration process is like this. Tested loaders SQ PowerShell to collect data. All the files are then collected and archived. Based on our analysis, these archives will be named after host names. Then these files will be transferred via SMB shares, and all of them are placed in a special directory called sysval. This folder is quite unique because it's a folder that contains all of your AD policies, and this folder only exists in DC servers. So let's assume that you have set up several DC servers and in your intranet, and all of them have joined the same AD domain. How do these hosts know the latest AD policies? The answer is a mechanism called Distributed File System Replication, also known as DFSR. So Windows will try to synchronize all of AD policies between multiple DC servers by replicating the sysval folder to all of the DC servers. This means that in this case, all of the stolen documents will be synchronized to all of DC servers. Then, the threat actor uploads the exfiltrated documents from one of them. We also find another tool called Aldris. It's an exfiltration tool based on OneDrive. It takes only one argument for refresh token. All of the files with a pattern.z in their names will be enumerated and uploaded. We also find another tool called Simple Box Spy. It was first disclosed in the Toddycats report. It can upload files to Dropbox. It accepts several arguments. The first one is access token, and -f is for specifying the files to be uploaded. It will upload files with specific patterns in their names, like .z, .7z, .001, and so on. We also found another interesting tool which we detected as Simple WebEx Spy. It's an exfiltration tool based on Cisco WebEx. It reads the configuration file or the embedded blob to get the tokens for Cisco WebEx. Then it will collect all of the documents and save to a folder called RSZL. All of them will be archived and uploaded to a meeting room called Welcome Space. So let's continue to the next section, attribution analysis. We also observed some connections between Kurma and multiple APT groups. For example, Kurma has connections to Operation Tunnel Snake due to Moria. Kurma can also be linked to Lensfly because of code overlap in MNload. They can even be linked to Toddycat because of Simple Box Spy and the same victim. In one of the cases, we noticed that Kurma and Toddycat appear around similar periods. However, we didn't see any strong overlaps or connections like process execution between two groups. We also see that Kurma could be linked to Sharpanda because of Victory. Most of all, they all have an interest in Southeast Asia. So based on our attribution, Kurma have some kind of connections to the four groups because of the tools overlap. However, there's no other strong connections like CNC infrastructure or process execution overlap between them. So that's why we decide to separate this group from them. We also conclude some common providers used by Kurma, like SNNET, Calpool, or Vulture. Among the infrastructures, we also notice some overlaps, like shared certificates or share certificate emails like dfg@gmail.com. So let's go to the conclusions. So here's a diamond model for this group. Let's recap their TTPs. So for the adversary, Earth Kurma, it has multiple capabilities like multi-stage reflective loading rockets, or it do the CNC communication by TCP hijacking or based on 6-core WebEx. And exfiltrates data via DFSR or via Dropbox, OneDrive, or WebEx. For the victims, they target industries like government and telecom. They also target countries like the Philippines, Vietnam, Brunei, Malaysia, Thailand, and Indonesia. For the infrastructure, they use some providers like XNNET, Calpool, or Vultr, and so on. So here's the conclusions. So based on our analysis, the attackers keep evolving and improving their arsenals. They're well capable of adapting to the victim environments, leveraging native mechanisms like DFSR and trusted platforms like OneDrive, Dropbox, Cisco WebEx to hide the footage. In order to mitigate such threats, please monitor the connections to legitimate clouds initiated by unauthorized applications, or analyze anonymous intranet connections with high traffic volumes, or enforce group policies to block the installation of untrusted drivers. So here's the tables for indicators of compromise. And that's all for today's sharing. Thanks for listening.